Okay, works. Cool. So here I am today to talk about the future of digital identity. So for context, I go by dcbuilder on X and several other places. I'm a research engineer at the Worldcoin Foundation, where I run our grants program. I mostly do the technical side of the grants program, so sourcing different grantees to work on things around cryptography, protocol design, scalability, a bunch of other things that we have problems with. And prior to that, I was an engineer at Tools for Humanity working on the protocol side of Worldcoin, essentially the smart contracts, circuits, etc. So today, I want to talk about digital identity and essentially the current status of it, where we are, where we're headed, sort of what problems do we have, and where sort of new technologies are going, and sort of the specific technologies that we are building in crypto and with modern programmable cryptography. We're able to essentially create a new space of digital identity that actually represents our values as opposed to the ones that we have today. So if you look at what we have today, right, the current identity systems are terrible. They're all siloed databases on servers that are owned by Amazon, Meta, Google, all these big Web2 companies that own all of their data, and then they're able to provide us services for free in exchange for our data, right? So ads, targeting of different product placements, right? All these sorts of things. We're sort of auctioning our attention and data for free services like social media, I don't know, marketplaces, YouTube, whatever. So essentially, we have all of our data is not owned or controlled by us. We just usually click we agree with this cookie or we agree with this terms of service, and we just auction our data for free, and then we have no ownership of our data whatsoever. And they can be leaked, right? So if the data is on a server, we've seen things like Cambridge Analytica, Facebook data, like phone numbers, names, addresses, or the ledger leak, like the ledger marketing leak, right? Essentially, all of your information can be found on the internet. And that is something that is terrible. And everyone knows it, but we've just sort of assumed that that's the way that it should be because there's no other way to actually do it properly. And the incentives just don't work in the pay model because we already have 100 subscriptions and we don't want to pay for 1,000 or 10,000 subscriptions for all the services we use. So another big problem is that they're not interoperable, right? My digital identity profile on Facebook is not usable on Twitter or on YouTube, right? If I have a YouTube channel, I, for example, don't have access to the emails of my subscribers. So I'm not able to even send them an email. So I don't own my own community. If YouTube tomorrow decides to ban my account, I lose my livelihood, I lose my graph of friends or graph of watchers or subscribers. I don't own anything about my personal identity, pretty much. It's privacy invasive, it's self-explanatory, centralized, right? We have no control over it whatsoever. There's just a few parties. KYC and KYB doesn't scale, right? We've seen this happen many, many times. Now we have deep fakes, essentially generative AI that are able to essentially sort of bypass all of these KYC checks, on exchanges, etc. Essentially, users have no sovereignty. I don't own anything. I'm not able to do anything about my own data. It's not interoperable. It's siloed. It's just terrible. And I think everyone is very familiar with how this is, but we just tolerate it because all of the other things that we get for it are very, very enticing. But it doesn't have to be this way. So in recent years, in the last 10 years, the advent of programmable cryptography, or essentially new cryptographic schemes that we can use to sort of build systems that are more secure and private and better, have been emerging. The main four, I think, categories that most people have heard about in the last couple of years, especially since ZK became prominent, are these four. So zero-knowledge cryptography, right? How many of you have heard of ZK before? Raise your hand really quickly. Okay, most of you. Essentially, I think most of you have heard of ZK for the first time in the context of scaling, for example, for Ethereum scaling, or some from privacy protocols like Tornado Cash, etc. So essentially, you're able to prove a statement about some data without revealing anything else but the statement that you want to prove to some third party without the third party having to have access to anything. They're just able to verify a cryptographic proof that I'm over 18, for example. And I can prove to all of you that I'm over 18 without revealing to you that I'm actually 22, right? I can keep the age private, and I can reveal to you just the statement. Fully homomorphic encryption, or FHE. FHE allows us to perform computations over encrypted data, right? So the way that it works is that I encrypt X and then perform some function on top of the encrypted input. And then when I decrypt that result, I get the f of x operate on top of the original input. So essentially, I'm able to compute on top of private data, and the person doing the computation never learns what the information they're computing over is. But at least you get this sort of private compute feature. Multi-party computation, or MPC, is a type of cryptography that allows you to split computation across multiple networks, or nodes in a network, or participants, as they're called. Essentially, you're able to split computation, and in a way where you know that the result was computed correctly, and as long as like several members of depending on the protocol, as long as several participants don't collude, you have a guarantee that the computation was performed correctly, and the people in this multi-party computation protocol don't learn what the other participants have as data. So you're able to do private computation in a verifiable way over a network using modern cryptography like linear secret sharing schemes and other things. And for example, one of the ones that George mentioned is TEs. So trusted execution environments are these pieces of hardware that are able to give you signatures over the things that they computed over, right? So if in the case of a GPU, GPUs can like process lots of matrices and operations, etc., like perform matrix multiplications and whatnot. And you're able to sort of have a signature that, okay, this actually was computed inside of this trusted execution environment. And as long as the hardware was not compromised or that there's no backdoor, you actually have some form of assurance that the computation happened correctly. So through these sort of fundamental cryptographical technologies and hardware, we've been able to sort of create new mechanisms, or people in the community have created lots of new mechanisms that we can use to build other application solutions protocols with. If you want to read more on these, I do have a QR code for my article, like full-length article that I wrote on this. So don't worry if you don't understand any single one. Later you'll have a QR code you can scan to read more about them. But essentially now we're moved to a world where we have data, but the data lives on different places, right? It can live on Ethereum, it can live on Arbitrum, it can live on a website, it can live on Uber.com, my bank account, my bank website, it can live on my phone. Essentially, data that is in all sorts of different places. But to this point, we have no good way of actually making proofs about that data or communicating things about our personal identity. But with ZK, we're able to sort of verify provenance proofs. Like I know that if it's on the blockchain, I can verify a storage proof, right? That some state is included into the Ethereum state tree, and I verify that in ZK, and then I'm able to consume that data and make statements about it. I can prove to you that I own dcbuilder.eth without revealing to you which address I have it on, although that's sort of a bad example because you can just search on the registrar. But you get my point, right? I can make proofs about emails, right? I can prove to you that I received an email from, my friend George about something, and I can tell you, like, this email contained this, and it came from this email, and you don't even have to see it, like, right? I can just prove to you that that actually exists. And many people have been building lots of these sort of tools, like zkKYC, right? I can prove, like, which nationality I'm from. I'm Czech, right? So I can prove to you that I'm Czech without revealing to you my passport. And you actually can verify cryptographic statements. And not only that, but with modern advent of programmable virtual machines or programmable environments that are provable, zkVMs or zk coprocessors, I'm able to just do general computation over any data, right? So I'm able to take the data from the email, take the data from my Google account, take the data from my passport, and some data that I have on-chain and some data I have on my phone. I can put it in a general programmable environment and do anything with it. I can prove to you that I'm over 18 and that I'm World ID verified and that I'm from this country and that I've done something and something on this website, that my League of Legends rank is over whatever master. I can do any arbitrary statement about my data. And as long as the data is not compromised or the provenance proofs are not spoofed, right? So for example, if, Uber lies from the API and I make a proof about the Uber API, then you do have some trust here, but essentially it's a lot of tools that allow you to make really useful primitives and build them with, right? So this is sort of like what I've been describing so far, right? You have data, provenance proofs. I can put that into a general provable environment, whether it's a zkVM or a zk coprocessor. Many of you have heard things like RISC-0 or Last One Jolt or SP1 from Succinct or all these zkVMs that have been built by rollups, right? Like the zkVM from Scroll, Polygon zkVM, or Starknet, or all these programmable environments. We're able to just do computations about all these things and then prove it to anybody else. There's also a bunch of other companies like Nebra, LineLayer, and other places that are building proof aggregators and proof marketplaces that allow us to compose these statements and verify them in just one single go. Within crypto, like there's also a big trend around intents or just declarative programming, where I, as a user, I don't have to care about having to get all of this data and make proofs about it, but some other party just tells me, hey, in order to prove to me that you're trustworthy, I need data from so and so and so and so and so, and you just, as the user, you just fill it and create a proof client side, and you don't reveal anything else. So essentially just this automates applications so that the user has to do as least as possible, but still preserve privacy and the features we care about. And then ZKML is just useful for like proving that, for example, if we use some inference on top of this digital identity, at least it's provable, right? So if we're, for example, proving to a protocol that we want to be credit worthy to get a loan, I can give it all my information, and then this protocol can judge me in a fair way, right? Using ZKML or provable ML, you can have some sort of classifier model that tells, oh, this person is credit worthy, this is not credit worthy, X, Y, Z, right? And you can have it all fair and provable to anyone. So essentially, these technologies allow us to move to a future that is the complete opposite of the current status quo, right? Our data can be owned by ourselves. I can have all of my data owned by me. And I don't have to co-opt into these sort of like the standard status quo where I have to give all my data away, right? Instead of having a social media network that is controlled and graph that is controlled by a central entity like X, I can use something like Farcaster or Lens or whichever is going to come next that is decentralized, right? I have my own graph and I'm able to make proofs about it. I can keep it private. I can choose what I want to do with it. Not just for this, but like decentralized YouTube, decentralized whatever. I can own my content, I can own everything, and all of these systems will be interoperable because everyone can just make proofs about things, and they run in a centralized setting by default. So it's privacy preserving, scalable, decentralized, like all the features that we want. The only problem with this is that right now the maturity of the technology is not there, and the incentives are not there either, right? We need to create some form of sustainable business models around decentralized technology and align incentives, because we've been doing it for replacing the monetary system with Bitcoin, Ethereum, and L2s and all these things that we've been building over the couple of years. For money, it's worked, but we've not really cared that much about digital identity. And I think this is like one of the major unlocks for future technology, right? Like if we want to build applications that are truly self-sovereign, not only does it require to have some form of censorship-resistant decentralized money, but you also need to have decentralized censorship-resistant data, and so that people can consume data in a way that is verifiable and just disclosure-based, right? I don't have to reveal anything unless I want to. And I have full control, and everyone like has incentive alignment in some way, shape, or form, right? So this is pretty much the major content of my talk. I usually try and keep it short because many people want to elaborate on different questions. I do recommend you scan that QR code because that's the article that explains all of the different parts of this and elaborates a bit more on it. It's usually really hard to go over it in detail and like go into the nuance of things because it just takes time to explain. But yeah, that's like the introduction. I probably will write up a follow-up in the next couple months, probably, because there's lots of things happening in this space. But yeah, I'll leave you guys to ask questions, and thank you for listening.